how classical gates work and how their equivalent works in the quantum world. So now we want to talk about more specific concepts, that is the reversible gates. We have also reversible gates in the in the classical settlement. So, for example, not applied twice gives the same result. So if I apply not to 1 in the classical world, it will give us 0 and again 1. But this also works in the quantum world. So if I have the qubit x and I apply it not twice, it will yield me the x bit, because as we saw in the previous section, not multiplied by itself gives us the identity matrix. So I basically don't change anything about the vector x. Now we can achieve more specific purposes with those gates. So I can, for example, make a control NOT gate. So this is called a C NOT. That does the following thing. I give it a controller, that is x, and an input, that is y. And if the controller is 1, so if x is 1, then the result will be x XORed by y. And if the input is 0, then the result will be just y. So this is represented by that, and here we put the output. Why this works as a NOT in the case that x is 1? So if x is 1, then our result will be 1 XORed by y. And this, what basically happens, this gives us not y. Okay, and now as a more general concept, we can see that if we apply this twice, this will give us exactly the initial result of y. So let's say I have a controller 1 here. I have exactly the same gate here, and I apply it twice. Let's just denote it by C naught now, as we know how it looks. This is the y, and here x remains the same, as you can see up there. And again, we do exactly the same thing. And now if we apply the C naught gate twice, what will be the result? This remains the same, as you can see here. And now we just have to put the first bit here, that is x, XOR it by this result. So this is again x and y. Finally, this we can see that if we XOR x with itself, it will give us 0. This XOR 0 by y will give us y. So this is basically how reversible gates work, and we can control them really simple, in a really simple